everyone, and welcome to today's SANS webcast. Packets don't lie. What's really happening on your network? Sponsored by LogRhythm. My name is Carol, author of the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are Dave Shackleford, SANS analyst, instructor, and course author, and Rob McGovern, Senior Technical Product Manager at LogRhythm Incorporated. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Great, thanks so much, and thanks everybody for being here with us today. Excited to be here because, to be honest with you guys, up until pretty recently, I sort of had the impression that packets could in fact lie, right? And I was proven wrong. All right, all kidding aside, the title is of course sort of alluding to the fact that we need to get down deeper into the traffic that's going through our environment and not only be able to take a look at that from a variety of perspectives, but be able to really assess that and analyze that at scale. And so I was pretty excited to have the opportunity to review a LogRhythm product called NetMon, which they offer in a freemium edition, which is pretty cool because you can go out there right now and get a hold of this and bring it into your own environment, put it to use pretty rapidly, and I'll sort of walk through all the fun and exciting things that I got to try here. But you can actually take this and immediately put it into practice with basically everything I'm about to talk about right now. So pretty exciting stuff, and really geared towards fundamentally taking a look at your network traffic and sort of starting to do things with that. So here's our speakers again. I'm excited to be joined by Rob. I'll be transitioning this over to him after I sort of go through my spiel and introduce things to you guys, and he'll really give you a more in-depth look at the actual product itself. But I will start us off by simply saying that we really just need all the help we can get. In the world of detection and response, the more visibility we've got, the ability to really see what's happening in our networks for a million different reasons, whether it's bandwidth hogs, whether it's some sort of command and control channels, whether it's known bad actors or bad traffic patterns that we can identify, anomalies in the network that sort of show up as blips on the radar. I mean, all of the above. All of these things are areas where every size organization needs help, and I see enough of this sort of traveling around and working as a consultant to really feel confident in telling you that tools like Network Monitor are going to do nothing but help us out. So I focused on some core things in the review that I went through, and coming from a network background and really coming from an intrusion detection background, these were all things that were sort of right in my wheelhouse, and I was really comfortable very rapidly jumping in and taking a look at all of these different things that are listed. Usability, of course, anything that's really difficult to use, people tend not to use or tend to not get the full sort of capacity out of. So we'll start with that as usual. But after that, of course, you're going to get into the meat of things, which is what you really care about as a security professional. And so that's going to be things like traffic identification and profiling. It's going to be looking for patterns, drilling down into the different types of sources where we're seeing traffic originate, looking for things like sensitive data and performing different types of DLP identification and potentially even remediation to some degree within the environment, network forensics, packet capture, you name it, right? There's a whole litany of features available in this tool, and I got to explore the majority of them. So I had a lot of fun. I think you guys will appreciate the types of things these guys have brought to bear in this product. So I started out with a very sort of simplistic test environment, and the folks over at LogRhythm were really helpful in sort of getting everything geared up for me, and were really handy in providing some different types of packet capture data that already had some, let's call it malicious or suspicious traffic that I could spot. So instead of me having to go out and browse all these various Russian websites and things, they had done all that hard work for me, which was really nice, and I appreciate it. But the nice thing is I was able to get this test environment up and running incredibly fast, and I think you would find the exact same thing to be true. It's really very easy to install and get set up, and once it's up, and running, you're going to find this really easy to sort of navigate dashboard that I think anybody familiar with LogRhythm and the kinds of tools that they've created over the past years, you're going to look at this and go, ah, cool, right? They sort of brought a lot of that just general UI design to practice here as well. It's not hard to find your way in here. You can find menu items really fast. There's nothing that's sort of question mark, what is this? You can drill into things really fast. I mean, I'll get to all that stuff here in a second, but even just looking at the base interface, it's got a, by default, update cycle of about 30 seconds. So it's going to go through and sort of do a refresh every 30 seconds, and by default, again, it's going to show you the last 15 minutes of activity. Now, these are things that can be tweaked and tuned. I didn't really go into a lot of different varieties of tweaking and tuning these things because this worked pretty well for me in my test scenario. But for some of you, you may need different sort of spectrums of time here. So you may need to do more rapid updates, and you also may need longer time periods that are represented here within the dashboard. But by default, you've got a nice, convenient web interface that you can navigate through pretty quickly. So jumping around, of course, what we care about is the traffic. So if you took a look at the previous interface, it was sort of showing you that base layout, and there's all sorts of customizations that you can do right there within the interface itself. So you can sort of pick and choose the types of graphs that you want to see and so on. But what we were doing was looking at just hey, what the heck is this thing seeing? What kind of traffic is coming through the environment? And we started drilling down in to that traffic. And so what you're seeing here is simply a drill down. And so we said, let's see the top applications by bandwidth or something like that. Let's basically find what's the big bulk of the traffic in our particular subnet and go drill into that and start finding out what's going on. So you can just click your way through this, and you can choose from the previous dashboard to take a look at sort of the various traffic types represented, and then go pick one of those, or anyone, to find out a little more about, say, where it was coming from and also when it was coming through. And so what you see here represented, and again, with these types of screenshots, it's always sort of, well, what am I really looking at? Basically, you're looking at a simple time-based representation of when this traffic was coming through. And so what you're seeing here, this is just our example, and it doesn't have any direct bearing on a case scenario. And we'll go through some case scenarios here in a second. But this is a bunch of syslog traffic. So in the particular test bed that we were actually using, there was a lot of log data that was being shipped around. And so you're seeing that. You're seeing that reflected here. Now, in your environment, I would guess that syslog data is probably not the bulk of what you have moving through the environment, but regardless of what it is, it's easy to get to. And so you see that showing up within a particular time spectrum. What we also wanted to do was start performing queries. And this is, of course, where the mojo of the interface really comes to bear, because we want to start finding interesting stuff, right? So it's not just, hey, what's my traffic pattern? I want to go and find the types of destination IPs, where is stuff headed to, where is stuff coming from? And so we explored a bit, and we just had some fun with some of the really basic types of queries. And this is one, we were just looking for a destination IP range and what kinds of traffic was destined for that range. So in this case, you can see it's an internal range from the 10.000 spectrum up through 10.3.255.255. And so in your case, of course, you might have a totally different range internally you were looking for, but we just wanted to see what was headed into that area. And you can see it breaks down very fast to show you the different traffic varieties and those time spectrums of when they were being sent. And of course, the vast bulk of the traffic is just a few different types here, but then you've got these little other slices in the pie chart to the right that should, if I wanted to, and obviously these aren't interactive screenshots, and I think Rob will really demonstrate this here in just a bit, I can quickly go over to that pie chart and I can choose any slice of the pie, which is great. I can just sort of highlight it and drill even further into that traffic and start pulling back, again, whatever it is that I want to see. And so I can find, for instance, just for what it's worth, let's say that I see this big spike of traffic that stands out on the bar chart on the left-hand side, this one sort of gray bar that just went off the scale at this one slice of time. what the heck is that? Well, I could very easily go over and sort of pick and choose that and delve into it. Down at the bottom, what you have is a little bit more detail that shows you the source IP and the destination IP and some applications and things like that. So you can start breaking down the different traffic depending on what's highlighted and sort of what's being seen in the environment. And again, it's all right there in the dashboard. So I can scroll through, I can dig in, I can go wherever I need to right from here. So this was, I mean, I don't even know what, I knew it was like the first 7 minutes of hanging out with this product. I was already doing all of this stuff, which was great. So it took me very little time to really just jump right in and figure out what was happening. What I started doing at that point was looking more specifically for, let's call it maybe more targeted profiling of traffic within the environment. So instead of just browsing around and seeing a generic dashboard that shows everything, instead what I chose to do was delve into a pre-built dashboard that these guys have built called the destination port dashboard, which makes a ton of sense. So I can go into this dashboard and you can see the sort of blocks of graphing that have been selected to put into here. What I've got is sort of the top destination ports that are noted within the environment, and I see that in a couple different representations. I've got a little bit more data down on the bottom, so you can see that we're seeing the destination ports and sort of how many times that's been seen. And I can really sort of take a look at that traffic in a lot of different ways. Now, why would I care about destination ports? Well, I think today most of us realize there's a lot of data to be gleaned from that explicitly. If I'm looking, for DNS traffic, or if I'm looking for traffic that's maybe been tipped off to me as potentially command and control traffic or something unique or different, or maybe just building on that idea of something unique and different, I just want to see if something stands out here. I sort of know my own traffic, and I know the types of traffic I should be seeing service-wise within the environment. What if I see something that's really bizarre or anomalous? I mean, what the heck is destination port 59234 or something? I don't know what that is. I'm going to delve in. And so that's exactly what we're looking at here. If we want to, I can delve in quickly and see not only the sort of biggest blocks of destination ports, and as you can see here, it's going to be things like port 80, it's going to be things like port 443. So I've got a ton of web traffic, and that's likely to be expected. But I've also got these other sort of major ports showing up, including DNS or port 53. I've got some other ones showing up that look like maybe port 88 or Kerberos traffic. Like I've got a couple that might be a bit more interesting, and so I can start going and delving into those as well. So those are places where, again, with just a few clicks, I can rapidly drill down and start finding out more detailed data about the types of traffic and really the port use or service use associated with what was seen by the product. So this is another capability that I explored within NetMon Freemium. So full packet capture, awesome capability, especially for anybody that's doing network forensics or has a need to hand off packet capture data to other other analysts, or even to integrate that into other evidence and so on. It's easy to do. So we can do file reconstruction really quickly and easily with with the product as well. So I can take a look at, for instance, somebody that's doing FTP, or somebody that's pulling files across a particular type of traffic. And I can grab all that data if I want to. I can also do file reconstruction if I'm looking for things like images and so on. So if somebody's up to something shady, or if I have some suspicions about something somebody's up to within the environment, and I can go and sort of take a look at that, that is a capability that is also here. So it depends on really what your goals are. If you're looking more for just what's happening in the environment and sort of how the traffic is flowing, that's one thing. But if you want to start delving down and doing much more rigorous investigations, you've got the toolkit to actually pull that off as well. So this was me just sort of exploring, and those were some core features that I think everybody's likely to be interested in. What I did during my review, however, and there's a lot of different case examples that I could have gone through. So we tried to come up with a few that would probably speak to most organizations and what their needs would be. We chose a few that I think you'll understand why. We sort of went down this road. Number one, coming from maybe a network operations perspective, I just need to know who's trying to get out to Pandora or other places that are hogging my bandwidth. And this is common. I mean, there's a lot of different ways to control network traffic shaping and to sort of control where people can come and go. But if you're just like trying to spot this stuff and see maybe not only where people are going, but where they're trying to go, and then maybe who the key offenders are, this is a quick way to do it. And so the nice thing is they natively recognize these types of applications. So I can just go in, and again, it's probably hard to see here in this screenshot, just because you're sort of squinting into the search bar. But native quick searches, application : Pandora. So that's it. If I am looking for Pandora, that's not hard to do, and it'll go out and sort of scrub through all the traffic that's been spotted and tell me where Pandora showed up, and that's exactly what you're seeing here in this screenshot. So there you go. I've got obviously some offenders, and that's not saying that I've completely forbidden Pandora within my environment, but maybe I'm seeing a little too much of it, and it's worth having a conversation around, or again, maybe doing some different types of network throttling. So now I know where it's coming from. I also know when it's being seen, so perhaps there are certain times of day that people are doing this. Anybody that's worked in the network engineering field, you get this. You got to know these kinds of things. So here I can go and drill into just my generic bandwidth consumption. And so I can see top applications by bandwidth use as a histogram chart. This is immensely helpful to just get an idea for what type of traffic is being seen, first off, as we said earlier, but also when it's being seen and maybe where it's coming from. And so now I get the bigger picture. If I want to go look for one particular app, I can, but I can also just delve in or dive in and sort of see, hey, what is actually being seen in the environment. So I can see some Skype traffic, I can see some SSH traffic, I can see people going out to Office 365, I can see Amazon AWS, I can see a whole bunch of stuff. Ideally, all things that are allowed and expected, but maybe things that aren't as well. And so this is a quick way for me to just get a big picture view of what's happening in the environment and sort of go a little bit further. Here's another case. So why in the world is all this YouTube traffic sort of being seen in the environment? Is there just something fascinating, or are there amazing and hilarious new cat videos that perhaps I myself need to go view right now? And of course, that's my running joke, is that no one can resist the allure of incredibly funny cat videos. But look, it's killing our bandwidth. So we got a lot of people going out to YouTube, and we really want to make sure that this is something that we understand why they're doing it, and maybe make sure that it's not some sort of new fangled command and control channel or something more malicious in nature than just people watching funny cat videos. So here I go. I can look up application YouTube. I can also see where it's going, where it's coming from, who's doing it, when they're doing it. As I said, all this stuff just, boom, pops right in and quickly shows you this stuff. So this also gave me an opportunity with the LogRhythm team to really jump in and see what they call their deep packet analysis, or DPA, rule sets, and the language that was in use to create those rule sets. And these are just, and again, I know it's probably hard to sort of squint in here and just see all these, but they've got a ton of these out of the box, which is just awesome. So I really didn't have to go in and create anything from scratch, although you could, certainly if you wanted to, but you can go in and look for specific types of things related to, let's say, peer-to-peer traffic, or certain types of data, or specific types of sort of web traffic, and so on and so on and so on. So they have this nice litany of rules that you can apply very quickly and search for very specific things. And the flip side of that, of course, is not so much just searching for those things, it's generating alerts and sort of triggering that next phase of perhaps detection and response cycles that would then lead you to go investigate stuff. So we went in here, based on our bandwidth use scenario, and took a look at a specific rule set that was associated with this whole notion of just tons of YouTube traffic. And so the other thing that I got a chance to do was investigate their PCAP replay capability, which is built right into the tool. So for any of you that have ever sort of rigged up, network labs where you've desperately tried to use things like TCP replay to sort of cast things back out onto the network and so forth, they got you covered, which was awesome. I was just so excited about this, I can't even tell you guys, because I had the ability to take a PCAP of a bunch of YouTube traffic just so that I could see it immediately coming through and generating alerts. And then, again, loading up some of the DPA rules specifically for YouTube, and then going in and doing a PCAP replay, which is a simple matter of search for your PCAP, load it up, and it shoots it right through. And then you can immediately come back over into your alarms dashboard, and we saw the YouTube outgoing rule we had created pop right up there, which was just killer. So it was awesome for doing real-time testing. So for any of you guys that have, and many of you probably have gone through this, but if you have sort of wrangled network, say, IPS rules in the past, or, any sort of detection rules, whether it's firewalls, IPS, whatever it is, this sort of pulls it all together for me. It gives you the ability not only to do these awesome detect rules, but to test them all in one platform versus having to go somewhere else and sort of mix and match tool sets. So really convenient, just enormously helpful for any network security analysts out there that have to do this as a regular part of your day job. So yay, awesome. Yeah, easy use right there for you. Next use case that we wanted to go through was something a little bit more tactically relevant for the security side of things, which is network malware indicators. And there's millions of these, of course, we know that. But what we're looking for here are sort of those glaring signals that something isn't right, right? The spidey sense tingling, as it were, that might indicate things like command and control activity or something related to that. So we went back over into the destination ports dashboard that you guys saw just a few minutes ago. And what we saw was, obviously a bunch of different traffic that was predominantly web-based. So no surprise, once again, port 80, port 443, bunch of stuff. We saw a little bit of DNS in there. We also saw a fair amount of Kerberos traffic. And so we had a couple things that just sort of were, like, why are we seeing this stuff? So here's our dashboard again. So this should be a little bit of a recap based on what I showed you guys just a few minutes ago. And so if you look down here at sort of the bottom left-hand quadrant, and again, I don't know how well you guys can see this, but you're going to see the top 10 destination ports, and we've got a couple instances of port 88, we've got a couple instances of port 53, and in our scenario, let's call it our sort of known behavioral profile of the network, we're calling those a little bit unusual perhaps. So we want to go dig in a little bit, and so we filtered on port 53. And so this was, again, trivial to do right there from the dashboard. We could go click into the specific ports and, start sort of triggering into the, spotted activity. But here's the rub. If it's just DNS, maybe that's okay, right? I mean, let's make the assumption that we should have some DNS. What we didn't want to see was DNS. I want to see 53 that doesn't look like normal DNS. So this is where really one of the more powerful capabilities of the tool comes into play, which is the ability to recognize protocol specs and sort of the normalcy of those types of traffic. And in fact, you can see here, and it's sort of standing out, you can choose to exclude application DNS but associated with destination port 53. So in other words, everything headed to 53 that is not DNS. And down here you can see we've got two unique instances of that. So boom. What we see, if you notice sort of the highlighted field there, it's in fact Kerberos traffic that is being seen with port 53. So that's really interesting. So of course we're going to go drill into that. And so we're sort of taking this the next step and digging into port 88, but again looking for things that aren't Kerberos. So we're going to just start digging around and finding interesting stuff in the environment. And again, we've got some instances of this. So you can see we've got some really unusual stuff. We don't really know what that unusual stuff is yet, but it popped right out at us. And we can now start looking for things like the source IP addresses that are sending out that data, and you can sort of see that down at the bottom if you're looking. If you're kind of looking at the source IP column in the bottom, well, guess what? That is absolutely where we want to go from there. So we would go perhaps follow up and start an investigation related to those IPs in some other fashion. Other things we wanted to do, we're looking for spikes of traffic. So we're back into our destination ports, and in this case, we're looking for destination port 443. We just want to see, where that traffic is coming from and sort of when we're seeing it. And so here we've got this weird spike of traffic that pops up perhaps at an unusual time of day. And again, if you take a look at the timeline on the bottom there, this looks like it's hitting right at about midnight. Why in the world are we seeing a big spike of traffic at midnight? And so we can go dig into that traffic and sort of start finding things that might be going on. So in this case, actually, if I'm not mistaken, if I remember correctly, it was like a antivirus update that was cycling at that time, which was just fine. But we saw it quickly, and we could have found that in our environment. Just going back and taking a look at things like port and protocol mismatches. Again, this is an example where we can do some of the DPA rule sets that are specific to protocol mismatches with their ports. So you can build really readily triggered rule sets right around some of the DPA capabilities and put them into practice immediately. So it's not like you have to go build your own sort of really customized rules if you don't want to or have the time. These guys have actually done a lot of that legwork for you. And so they can immediately sort of notify you, hey, Dave, check it out. You have, port 88. That's not Kerberos. You have port 53. That's not DNS. You should probably investigate that stuff. So really, really handy. I'll wrap up here with, I think, probably the captain obvious of use cases, which is sensitive data identification. And so we went and dug in, looking at some of, again, the DPA rules specific to payment card data. And they've done all the sort of main matching models that you would expect for typical payment cards, the major brands and sort of all the data around those. And so then we used the PCAP replay to shoot that stuff through. So we had some, PCAPs ready to go and used that as part of our test bed, shot that through, and sure enough, saw some different types of alerting immediately come into play. And so what you can see here is sort of the top level, which is the data itself, and that's showing you that it was a DPA rule called detect credit card. And again, this was something these guys had pre-built. And then in the bottom layer, we're sort of seeing the detailed data. And so we're seeing, a bunch of different things that were spotted in that content. And of course, that matches all of the different rule capabilities that we were hoping to see. So that was a really easy one. And again, they had a whole bunch of different ones in there, things like social security numbers and just various other forms of data. So just to wrap us up here, and then I'm going to hand it off to Rob, I really had a blast doing this review. And the reason, I think, more than anything was, well, it's really twofold. Number one, couldn't get easier to use. I mean, I just can't sort of extol how great this was to just jump in and start making use of it immediately without an enormous amount of setup. Number two, there's a lot of capabilities here. And maybe number three, it's free. So awesome. Go get something that is immediately useful that you can put into practice right now and start taking stock of what's happening in your environment, and then even building on that to do things like forensics and investigation. So easier to use, better visibility, more insight into our traffic. And with that, I'm going to hand it off to Rob.
All right, thanks, Dave. I love that somebody is as excited about NetMon as I am. What I'm going to do is, instead of spending much more time on slides, I think I only have one more slide that I want to show, which is that we're going to transition into a demo, and I'm actually going to show you the live versions of some of the use cases Dave was showing you, and then some new things that we happen to have available in our environment at the moment. So at this point, I need to switch over and share a screen. All right. So what you're seeing is a live network monitor. This is actually attached to our engineering lab here inside of LogRhythm. So there's some very real data in here. There's some weird data in here as our engineers are playing around. We're actually in the middle of a contest this week, so there's some truly interesting behaviors going on. But as Dave showed, our default dashboard shows you the last 15 minutes of what's going on in the system. And we can do all sorts of things, like the application Pandora query as an example. The query bar up here, you can type in just Pandora, and it would find a Pandora match across any of the fields of metadata that we pull out. But in this case, we're narrowing it down to just things that are classified application-wise as Pandora. And then we can see the source IP, the destination IP, how long has the session been running. So somebody's been listening for 42 minutes. We can expand any one of these sessions and pull out even more data about that particular session. And the data that we see inside of each of these is dependent on the application. So I'll see a subset of things for Pandora. I'll see something different if I'm looking at a Netflix. I might see something entirely different if I'm looking at an application that we classified as Elasticsearch. Now, the query language is not all that complicated. It's actually built on, showing the wrong screen, there we go. Built on Lucene, and we have a full syntax guide. This is kind of a 2-page cheat sheet to get you going. So it explains all the characters. It explains some of the more common metadata fields you can query against. And then it has some examples down in the bottom of the kinds of queries that you can run, ranging from really simple, just want to look for Pandora, to the really complicated of look at certain desk ports but don't include 53 and 80. So this guide is available on our community portal, and it's actually part of our documentation as well. So switching back to the application, I'm going to go to a different dashboard now and go into our destination ports, because to me this is one of the most fun ones to play in, and I'm kind of like Dave. The first time that I started using this dashboard, I just get lost in it of how many interesting things you can go look at from both a security perspective as well as just an operations perspective or a hunting perspective. So as we can see, I've got a fairly interesting looking, we call it a donut chart, where the inner ring is showing me the destination port and how many sessions are hitting that port. The next ring is showing me the typical applications that are hitting it, and then the next 2 rings are showing me the top talkers on that port and that protocol, so destination port and source port. 53, 55 is actually, again, DNS. Not that big of a deal. The good news is I see that it's 100% DNS. I'm not going to worry about that one. 443, that's going to be our secure socket layer, a lot of web traffic going on. I'd expect lots of different types of applications, and sure enough, there's some HTTPS, some TCP channels going on, some named things like Office 365, Google, Outlook, Amazon. Not unexpected. Port 53 should also be DNS, but I see again there's a small fringe that isn't. So following Dave's example, what I can very easily do is click in just on port 53 on this destination dashboard, and then I can filter out DNS. So I'm going to click on DNS and change it from kind of the green to the red here, and see what was that 0.09%, because that's that low-level traffic that you're just not going to see otherwise. That is where the suspicion really lies, is somebody trying to use port 53 for covert use or something else. So now I can see I have 3 different applications that are not DNS. I've got some unclassified TCP traffic. Probably want to dig into that, especially since I'm seeing it's coming from a lot of places and going to a lot of places. Now, I can see most of these happen to be 10.128, so it's internal traffic talking to each other. That means it's something more likely under my control. But if I look at something like this one that has a destination of outside our network, that's a little more suspicious. I want to look at that a little faster or a little closer. Coming down here, I've got some broadcast traffic going out on that. That may or may not be a worry to me. And then I've got, again, that Kerberos traffic that I was seeing may or may not be a worry to me, but I see it's coming from, or always going to one particular server and coming from 5 well-known or well-identified servers. So now, even if it's an operational issue rather than a security issue, I have truly compelling evidence to have a real conversation with my IT operations team. I don't have to go to them and say, hey, why do we have Kerberos traffic on port 53? They say, no, you don't. Now I can say, we have Kerberos traffic on port 53. It's coming from this computer. It's going to that computer. It's happening at this time frame. We have all of the evidence we need to start a real conversation to identify, is it a problem or is it not a problem, and something we can ignore later on. Now, we can do all kinds of other fun things with this particular dashboard. One of the things, like I said, we happen to have an internal engineering contest going on, and one of the teams happens to be working with SmartThings devices. SmartThings, if I type it right, is Samsung's Internet of Things devices. So I don't know what that traffic looks like. I don't know what channels it might be on. I don't know if it's secure, if it's not secure. So I'm just going to throw smart things in my filter and see where I identify smart things at all. And what I can see here is that everything that I know about smart things, at least in the last 15 minutes, is going to destination 443. So that's going to be SSL traffic, hopefully, HTTPS. That's good. Can find the destination IP. It looks like it's going to 2 separate destination IPs. Now, I'm not going to do this here, but in the past I've gone and done a NS lookup on these, and both of them are Amazon cloud environments. So what we know already is that SmartThings Internet of Things devices are talking to Amazon, which may or may not have been obvious in the fine print when you sign the end-user license agreement. And then I can see which systems are talking to those. What's also useful here is that this is 443 in HTTPS. I can drill into one of these sessions and start looking at things like what's the certificate information. So this doesn't help me a whole lot. That's an acronym that I can't figure out for sure. But if I scroll down a little further, I'll say that the organization name is SmartThings. That's good to know. Go ahead and throw that up in my table. And the other thing I want to know is that is it TLS 1.2? So is this traffic secure? So if I'm not worried about having SmartThings devices on my system, I am probably still worried about how secure is it. And I want to make sure that if it's HTTPS, it's at least using TLS 1.2, which means it's going to be hard to crack into what that traffic is. But again, I've got a great conversation here. If this were a concern that somebody were doing this in my environment, I have a time, I have IP addresses, I have true evidence that it happened. If it's not a concern, I can still do a security check on it and validate that it's there. And even beyond that, I can start looking and tracking. You know, this behavior of seeing every 5 minutes another interval is kind of classic beaconing behavior. That's going to show up on some other kinds of queries or dashboards I might have looking for regular patterns of traffic. This one I'll happen to know is safe, but I can then filter it out as a false positive because I know exactly what it is. So again, this dashboard has led me into a kind of an interesting place. I've gone from a broad look at my network very quickly down to a hyper-specific look at a specific type of traffic. And the other thing I can see is that it's not doing very much. I only get one session every 5 minutes. And each one of those sessions is doing about 4K of data every single time, fairly steady. I can go to broader time frames. I can look at this over time. I can do all sorts of work with this again to then figure out and characterize this Internet of Things traffic that I may or may not have known anything about when I started this kind of hunting exercise through the destination port. So this is always a kind of a fun thing to play with. But another area that Dave talked about, and I really kind of want to emphasize a little bit, is our rules. We have 2 types of rules. The first type is the really simple type of rule, that if I go to any of my dashboards and write one of those queries, like looking for application Pandora, let's try that one, that's always a good one. I can click this button that says Save Rule, and I can say Pandora. Call it Pandora alarm. I'll give it a severity of low because I don't care about it all that much. You can try to save it, and the first thing that happens is I do get a quick check and say, how many times would this rule have fired in the last 24 hours? So in this case, what I'm going to see is Pandora fires an awful lot, 6,000 times in the last 24 hours. And that means that it's not going to be a good idea for my security operations center if I put this rule in place. They're going to get a lot of alarms and be really mad at me. So I might want to refine it or do something different to it or change like which IP addresses or make a little bit more complex query. But I can save this alarm, and now every time we see Pandora traffic, I will get an alarm raised. That's what I call a query rule. It's just based on filtering the data that you see in the dashboards. The other types of rules we have are deep packet analytics rules. These are much more complicated, or can be much more complicated, because they're based on a language called Lua script. So here's an example of a rule. This one is looking for peer-to-peer traffic types. So all of the known applications that we can classify that are peer-to-peer, there's a dozen of them. And what we're looking for is any session that's on peer-to-peer traffic that is typically going over a certain size limit, because that tends to indicate a file transfer of some kind. We could also modify this rule and have it look for how long the session is going. We can look for whether we allow these particular types of peer-to-peer traffic or not. And all of this logic can be built into the rule and then raise an alarm for us. And we can use that for both classifying traffic, like the peer-to-peer rule here, or we can look at it for more complicated things. And Dave mentioned the credit card rule as an example. And if you look at this rule, you see there's a lot more comments and a lot more code, because we're actually extracting sequences of characters and then running the checksum algorithm for each of the main types of credit cards on it. And if we see that checksum algorithm in clear text, we're going to raise an alarm on it. So to show some of these in action, I'm just going to replay some PCAPs. I've got a nice collection of PCAPs here. I'm not going to be real picky. I'm just going to replay back my whole library. Click Upload. And it's going to grab these files off of my local computer, move them into the network monitor device, run them back through the system. And now for any of the rules that I had turned on, I can go to my Alarms tab. And I should see all of those alarms firing. So I've got some clear text password traffic that I can detect. I've got some developer packages being deployed on production systems. I've got some rules for detecting credit card, social security number, and so on. And then the outer ring of this particular chart is showing me which application is doing it. So my clear text passwords is all HTTP. That's a pretty likely scenario for actually having misconfigured websites up. That probably means basic auth over HTTP, and that's something I'm going to want to look into fast as an alarm. On the other hand, if I look at credit card numbers, I can see some of it's WebSocket, some of it's HTTP. Probably look at the HTTP first. WebSocket might be second. There's some other things we've seen that are false positives in here. Credit cards have really weak algorithms for determining if it's a valid credit card sequence, and it turns out that those same algorithms are often used in other applications, so you have a fair chance of false positives in there to filter out, and you can sometimes get a quick view of that just by looking at the application. My developer packages, I can see that's all Red Hat updates, so somebody is deploying developer packages through Red Hat. And that's again, if it's against my policy as a company or I wanted to control it, that's going to be a really high confidence positive to go after. So I can see when those alarms fire, how often they're firing. I can see a count of how many different types of applications are firing that rule, as well as how many different systems from source and destination are firing it, as well as how many times the rule itself fires. And then down below, I can jump in and take a look at details on the rule. So in this case, it's a detect social security number. I can look at some of the metadata here. I can see where it was going. This is Cloudflare. It's a web application. It's going to a directory called questions. You can see what the user agent, can see what the sample of the credit card numbers were. There were 3 of them, and this is what they look like. The server Stack Overflow. It's a common website that developers are going to go to ask questions. And sure enough, if I scroll down further to look at the URI, I can see that this particular instance of social security numbers in clear text, the rule did exactly what it was supposed to, because it was going to a page called "Is there a social security number reserved for testing?" That's going to be a clear text page that has social security numbers in it. In this case, it was suspicious, but is it malicious? Absolutely not. This is just a developer doing research to try to figure out how to detect the credit card numbers. So good example of a rule firing and us being able to drill into it quickly, and very quickly, within seconds, we're going to be able to say, hey, this one we don't need to worry about. Next rule, kind of a pastebin curl, so we're looking for pastebin traffic with specific curl commands inside of it. And again, I can see kind of where it came, where it went, and I have some custom metadata fields that I can see that'll show me what the actual commands were inside of it. So a different kind of alarm. Now, DPA rules can go from super simple to super complex. These are just some examples of what we can do with it. So what else can we do with Network Monitor? We can replay traffic, we can run rules, we can run alarms, we can also send all of this information to a SIM through syslog. We also have a API layer that we're rapidly building out inside of this environment so that you can control multiple network monitors if your environment is big enough to need them, or you can do automation around the network monitor, whether by creating rules, turning rules on or off, adding new rules, or synchronizing systems between network monitors. There's a lot going on here. And as Dave mentioned, we have our freemium version, which is available for download, no cost. We have our licensed version, which ups a little bit of limitation on total bandwidth and data retention, and those are the 2 big changes with it. We have a very vibrant and rich community that's open around this, so even if you're not a LogRhythm customer, you can join that community and ask questions and see how to get things set up. And there's a couple of open blog posts if you go to logrhythm.com/blog. One was written by one of our security experts, Greg Foss, and some of our developers on our network monitor team about how to set up a network monitor in your home environment on a little micro unit. It's about $200. It's kind of the equivalent of an Intel NUC device. So pretty good instructions on how to get up and going. If you go to our freemium site, there's also a virtual PC image already turned on and enabled that you can download and run pretty much on any machine. And what that one's designed to do is let you start playing around with Network Monitor, looking at just the data that's going into and out of your own laptop, as an example, off of your own network card. So that's a great way to learn the system and learn the tools, maybe build some DPA rules or poke around and play. And it's also a great way to see what your system's actually doing, because there's always surprises in terms of what you send and receive across the network. So I know we wanted to save a little bit of time for questions. And there's a couple of last little things. I want to switch back to the slides if we can. And while we're doing that, if you happen to be coming to RSA, we have a big booth in the South Hall. It's number 1707. I'll be there, happy to answer questions, talk to you about Network Monitor. We're also going to be launching a first ever for LogRhythm public contest around Network Monitor Freemium that is all about building DPA rules, creating custom dashboards, and there's some pretty hefty cash prizes associated with that. So again, if you're at RSA, you'll see the live announcement of it. If you're not at RSA, keep checking back on our website and get the details on the contest. It'll be run through DevPost, all right, yeah, as the hosting company for that contest. So Dave and Alec, anybody else have anything you want to add, or do we open it up for questions?
All right, well, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question came quite a while ago. He was asking, can you talk about integrating threat intel feeds into this? So it was during Dave's portion.
Sure. So threat intel feeds, we kind of handle that two different ways. One way is that Network Monitor is a LogRhythm product, and we pair very beautifully with our LogRhythm SIM environment, which has a full, rich threat intelligence service as part of it. So using our syslog output to go into the SIM, and the SIM acting as that threat intelligence manager, that's the normal way that we look at threat intelligence with this, is that the advanced intelligence engine and the correlation rules will be firing off of the data that's coming from here. So in that case, Network Monitor is just a data source, and the threat intelligence integration is handled on the SIM side. That's one approach. Another approach is we've actually built some DPA rules and some other things to help us look at threat intelligence on this side. There's some interesting challenges there, as there is with all threat intelligence, of how fast does the data age, and how do you keep it continually updated. So generally our Cadillac solution is tied together with a SIM that's doing the heavy lifting and processing, and has the vulnerability scanners, the threat intelligence feeds, the other rich data sources that you can then correlate with network data to get a true picture of threat. The other side of it, again, is through some of the API and automation or deep packet analytics, being able to tie things like the IP addresses here or IP ranges here to reputation feeds or other information about known MAC addresses or known IP addresses.
All right, thanks, Rob. Is this a span port-based deployment? If yes, what is the scalability for enterprise?
That's a great question. We're definitely out-of-band processing, so we're looking at a span port, a tap port, or a tap itself on the network. We currently will sell, from LogRhythm, we'll sell dedicated appliances that have 10 gig network cards in them. And the license levels will go up to, I think we do a sustained license of run it forever at 5 gigs with spikes up to 10 gigs. For scalability, we tend to see two approaches, and it's usually a mix of both at enterprise level. One approach is to put a network monitor behind a packet broker, something like a IXIA or Gigamon type device, and that's sitting out there in front, and then using the packet broker to selectively direct the more interesting traffic to one or more NetMons, and then again pull the network monitor data and analysis back together in a SIM environment on the far side, or again using the continuing changes we're making with the automation and API layer to help tie things together and keep everything in sync.
Thanks. Is the freemium product completely localized, meaning is any data sent to a centralized system or cloud?
No, actually NetMon itself is completely localized. Everything stays on the machine that the tap is running to, except for that output feed that has either our alarms or diagnostic messages or a subset of the data that can be forwarded, again, onto a SIEM as an example. But no, we're not pulling into a centralized cloud environment. None of this comes back to LogRhythm. It all stays wherever you have your network monitor.
All right, thanks, Rob. What surprises you about the evolution of network monitoring capabilities, and what continues to be missing?
I don't know, Dave, if you want to start with that one, and then I can give my answer. Or?
Well, yeah, so I'm actually sort of scratching my head. I'm like, what's missing out there? I think in a lot of cases, at least what I tend to see is, it's almost an issue of scale, right? So if we're looking at, sort of the toolkits, I think a lot of the tools that are actually available now can get the job done. I mean, can we inspect traffic at typical speeds seen in the environment? I think reasonably, yeah, within most people's environments, that's probably doable. Can we identify and profile applications and protocols that are, again, at a reasonably accurate level? Yeah, I think we can. The bigger challenge that I see, and where I think maybe there's room for improvement, for most of the process-wise, and maybe more than that, is, hey, what's the behavioral baseline really look like over a period of time? How do you develop that? How do you start picking out things that are unusual in really, really busy environments with a lot of different traffic types? That's a tougher thing to pull off, because it requires some knowledge of the environment, and I don't know that any tool is just going to auto-magically do that exactly for you. So, in my mind, if there's one big shortcoming in the world of network monitoring, it might be more around, kind of large-scale anomaly detection and making that easier. That's just my thought.
Yeah, I think I generally agree. I come at it from a little different perspective, because I came into network monitoring more from a security side rather than from hardware or IT operations. And what I saw with the platforms and products that are out there is there's lots of specialty or niche things you can do. I mean, if you just want to capture network traffic and write it to disk, there are dedicated solutions that do that. But it's really, really hard to dive into those from any kind of analysis perspective or find the needle in the haystack. There's also programs or applications that do a really great job of that analysis, but they just can't do packet capture, or they can't process it at speed, or there's all kinds of other end-to-end experience issues there. To me, what I feel like the evolution of network monitoring is a couple things. The first is kind of the goal. It's gone from hardcore network engineers who are trying to answer the question that if anything goes wrong with the system, it's either the network, the database, or the application, and whoever's in charge of which group blames the other one. So how do you get evidence to show what's going on? It's gone from that arena purely to this broader security arena where we don't necessarily care so much, or even sometimes even know what the underlying network infrastructure is, but we have to be able to look at weird patterns and lift out low-level signal in something that's a really noisy system. So how do you build that kind of end-to-end experience for a broader audience to be able to understand and see and lift out interesting things without necessarily having to dive deep into the realm of TCP replay and are we going through VLANs or are we not going through VLANs? At the end of the day, that doesn't matter as much until the second conversation, once we figured out that something that was interesting is suspicious or malicious and we need to investigate. So to me, the evolution is really how fast can I get qualified, interesting events, and then from there dive into to whichever direction we need to go. And a lot of the tools out there are starting from the other side of the approach, where you get way too deep in the details and you lose sight of the impact of what you're looking for, or you just don't have the capability of pulling it all together, whether you have the full peak caps and you have the time and you have the metadata and you have the classification that helps you find, understand, and build an evidence case around whatever it is you're looking at.
All right, thank you. How long can I use NetMon Freemium for? Does it expire?
NetMon Freemium does not have a time expiration on it. Like I said, the main difference between Freemium and the live version is going to be how much bandwidth you can take in, and then how long the data storage is for. On a freemium, you get about 3 days worth of metadata, and then we recycle it. On the enterprise version, it's more scaled by the hardware underneath as how much storage you have. And then the bandwidth limit, a freemium environment will take you up to a network of 1 gigabit per second. And then the enterprise versions will license up much higher than that. So it's not time-bound in the sense that you download it and 30 days later it's going to shut down on you. It is time-bound in that you keep 3 days of data and you can't go back further than that.
All right, thanks. A pre-built virtual machine was mentioned earlier. Where is that available again?
If you go to logrhythm.com/freemium, sign up through our sign-up page, you have the choice of downloading. Actually, you can download both pieces. You want to download the VirtualBox image, which you can just start running with, or you can download the full installation, which you can then put on your own hardware or virtual machine and run in your own environment. But definitely logrhythm.com/freemium is the place to start.
Okay, thank you. Can the monitor pull in and analyze log traffic data from other systems?
Generally, the way a network monitor is designed, so we wouldn't do that because we're looking at the raw network traffic. If we have log data from other systems, we would generally feed that into the SIM instead. And the one place where that gets a little blurry is with more classic network monitoring tools, things that do NetFlow or SFlow, in which case what NetMon can see sometimes will duplicate that rather than pull that in and try to reuse it. Because when you look at the NetFlow or SFlow, you just don't have the rich metadata in almost every case. You have kind of the source IP, dest IP, source port, dest port, and total bandwidth, but you don't have the deep packet inspection layer. So we don't tend to use network monitor that way. That would be something that we push into the SIM side of the world.
All right, thanks. Is Smart Response part of this demo, or can you explain what that might look like in the GUI interface?
Well, that's a great question from somebody, and as a technical product manager for Network Monitor, my other team that I work with is the LogRhythm Labs team that's responsible for all of our Smart Response plugins. Smart Response is a extensible framework that we have in our SIM that allows, based on alarms, you can automate responses to alarms for remediation of problems. And then in our brand new release, you can actually be able to use smart responses inside of the web interface to do context enrichment of data. Network Monitor doesn't have a smart response plugin component inside of our UI or our element. The closest we would have would be things like deep packet analytics rules. The use case is a little different because Network Monitor is out of band. It's just capturing and processing the data. It doesn't have a way to react or act on that data in line or in stream. So we're again kind of leaving that in the SIM side where you can run a smart response and talk to a Palo Alto firewall or something as an example and tell it, hey, go start blocking this traffic. What we are very actively doing, and will be coming fairly soon inside of the SIM, is building a smart response plugin for the SIM specifically for Network Monitor. And what that's going to let you do is from the SIM web console, with just sort of a right click, you'd be able to create alarms or turn alarms on or off or control whether we're capturing data on the network monitors. So great question, but it really ties together LogRhythm's Network Monitor and LogRhythm SIM environment.
All right, thanks. I think we have time for one last question. With a limited budget, how do you find balance between investing in network monitoring tools and staff to respond to threats?
I don't know, Dave, you got an opinion on that one?
Oh, that's like the most loaded question of all, right? I mean, look, there's a lot of answers we could give, and I'm sure Rob's probably chuckling here as well because it is a tough one to answer. How do you get more money for your program, right? Well, I think first off, I'll just say what it is. When vendors like LogRhythm release products like this or capabilities like this for low cost or no cost, it just helps us all. I mean, we really have to be grateful that those kinds of things are available, and that's going to help the situation. But for staff, really that's the age-old question, right? How do you get more staff? I don't have an answer for that one. I mean, the only thing I've seen work, is sort of making it obvious that the current staff cannot meet very specific requirements that are impactful to the business, right? So if you find that there's things going on in your environment that could potentially be harmful and you're missing them, and you can show that, you know, it's people and it's bandwidth that just wasn't there for the team, sometimes that can be helpful, but man, that's a tough one. I don't know, Rob, you got anything?
Yeah, I have a couple of thoughts. I mean, the LogRhythm as a company, this is something we run into all the time, and it's one of our core missions really is to provide that advanced knowledge as much as we can and to automate as much as we can, so that that you don't necessarily need as many or necessarily as highly skilled analysts to be able to detect the critical things that are going on inside the network from a security perspective. So that's part of why we invest so much in things like smart responses and deep packet analytics rules and our knowledge base and how often we update it. So from a vendor perspective, we're trying to do everything we can to help lower the burden there by making it easier to get into the system, easier to use the system, easier to find interesting things, so that there's less education time, less ramp-up time, less, well, what did I do in this system versus that system, and just try to make it as easy and straightforward as possible to get that end-to-end story in place. From a consumer side of it, to me, the network side is a huge blind spot. I mean, this is the world that touches our systems every single day, and it is to a very large degree, back to the whole title of the talk, that is the fundamental truth. If you have someone in your company that got hit with a crypto wall or a ransomware, by the time that they tell you about it and it's become a security issue, you ask the first question, well, where did you go, or what were you browsing that downloaded this, or which file did you open, or which email? And your responses are either the embarrassed, I'm not going to tell you, you're the security expert, you figure it out, that was 5 hours ago, I can't remember how many different websites I've gone to in 5 hours or how many emails I've read in 5 hours. You need the evidence. So the network side is going to be that best evidence, because it is going to show you what actually came into the system, whether it was an email, whether it was a website. You can narrow down the time frame of when the bad thing happened to that system, and you can actually go all the way back to the source of finding where the malware came from, which you can't do if you're not looking at and capturing the network evidence. Our security operations team, I don't know how many times that they've done incident analysis both for us and for our customers, and the very first thing they say is, where are the packets? Show me the network traffic that went into and out of the system, because like what Verizon's data breach report from last year, I think 80% of all breaches that they could analyze and identify a source had a network component to them. So if you're not looking there and you're not capturing that evidence, you are missing the patient zero, that initial infection. And without that, you can remediate. You can blow away the laptop and restore it from a backup, but you can never really stop the attacks because you don't know how they got in or where they came from. And to me, the network is such a critical player there. We also like run freemium in your environment, turn on our system rules, see which one's fire. And the first time that you see all of your employees' social security numbers getting transferred by a backup process that's unsecure, that's a real easy sell to go to management and say that we need to invest in this area.
All right, well, with that, we are out of time. Thank you so much, Dave and Rob, for your great presentation, and to LogRhythm for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.